Today we will be talking about quantum numbers. Quantum numbers are a series of 4 numbers which provide information about the orbital of an atom. Before we begin, let's make sure you understand what an orbital is. Orbitals are a set of wave functions which provide information about where an electron is likely to be found in an atom. Quantum numbers provide information about the location and properties of specific electrons in an atom which reside in these orbitals. An important principle to remember when learning about quantum numbers is Pauli's exclusion principle, which states that no 2 electrons can have the same quantum number. N is the principal quantum number. The quantum number n always has positive integer values, 1, 2, 3, etc. N indicates the main energy level occupied by the electron, in other words, the shell occupied by the electron. These energy levels, or shells, refer to the distance from the nucleus. Higher values of n indicate electrons which are farther from the nucleus and thus have more energy. Technically, values of principal quantum numbers can go to infinity. However, as these numbers become larger, they become increasingly theoretical, as electrons are most likely to be found in lower energy levels. The second quantum number is L, also known as angular momentum quantum number. The quantum number L is found by subtracting n-1, where n is the principal energy level. This number provides information about the shape of the orbital. For example, for the quantum number 0, which is associated with the letter S, the shape is a sphere. In another example, for the number 1, the shape is a dumbbell and is associated with the letter P. This trend continues for larger values of L. For example, the number 2 is associated with the letter D, and the number 3 is associated with the letter F. The third quantum number is known as the magnetic quantum number. It can be any value from negative L to positive L. This indicates the orientation of the orbital. Here is an example of the different orientations of the p orbital. The dumbbells can be drawn oriented along the x-axis, the y-axis, or the z-axis. The final quantum number is ms, the spin quantum number. This quantum number has only 2 possible values, positive 1/2 and negative 1/2. These values indicate the spin of the electron. If the spin quantum number is equal to negative 1/2, the electron has a downward spin, and if the spin quantum number is equal to positive 1/2, the 2 electrons occupying an orbital must have opposite spins, as stated by Hund's rule. Another important concept relating to quantum numbers are their nodes. Nodes are points in the wave function where the probability of finding an electron is 0. There are 2 types of nodes, angular and radial. Angular nodes are nodes in the shape of the function. This means that the probability of finding an electron at the location is 0 on the graph of the radial probability distribution curve. Radial nodes are nodes created by the overlap of the radii of orbitals. Radial nodes can be thought of as a series of spheres with fixed radii, which increase as the principal quantum number increases. n-1 tells us the number of nodes, where n is the principal quantum number. The number of angular nodes is given by L, the angular momentum, and the number of radial nodes is found by subtracting L from the total number of nodes. We hope that this video has succeeded in giving you a greater understanding of quantum numbers and their implications for the structure of orbitals.